Hi guys, today we're going to talk about section 2-1, relations and functions. Our objective is to use new vocabulary words: relation, functions, domain, range, discrete, continuous. We're going to use all those words to describe relations. Let's get started. So here's a couple of vocabulary words that I want to talk to you about before we get into things. The first word is relations. So a relations is just a set of ordered pairs where X is your input, Y is your output, or domain and range, independent and dependent. And you might see these in different forms, such as ordered pairs, or a table, a graph, or what is called a mapping. For your domain, that's the set of X values in your relation. It's your X coordinates. So whenever we would write this, we would write it your leftmost value and then your rightmost value with your X in between for your interval notation. Sorry, for your inequality notation. It's across your X values on your graph. In your mapping, it's the X values, and in your table, it's the X values. For your range, similar thing, but it's the Y coordinate. So all the Y values in your table or on your graph, it's from low to high or bottom to top, and then it's the Y values on your mapping as well. So here's the thing. Not all relations are functions. So a function is a relation when every element of the domain is paired with exactly one element of the range. Or another way you can think about it, every X value has only one Y value. So for example, these are functions because every X value, none of them repeat, they're only written once. And this passes my vertical line test, which is if I draw a vertical line, it only goes through one point at a time. Whereas, look at this side, these are not a function because this set of values here, the X values repeat. Or in my table, my 3's repeat. On my graph, this is a vertical line, so it can't pass a vertical line test if it's actually a vertical line. And then looking at my mapping, this 5, it has two different Y values, so 5, 4 and 5, 5. That would make that not a function. So we're going to find the domain and range of this relation. So remember, your domain is your X values, but you want to make sure to put them in order from smallest to largest. Whenever we're dealing with the domain and it's discrete like this, discrete meaning you're going to take each point individually instead of as a continuous graph. What we would have to do is write a curly bracket and then put my domain or my X values in order from smallest to largest. So -6, -5, and I'm writing the X values of each coordinate. -6, -5, -3, -1, and 6 in my curly bracket. For my range, I'm going to put all the Y values of these coordinates. And again, I need to make sure to put them in order from smallest to largest. So just because the X's were already in order does not mean that the Y values will automatically be in order. Because if I notice here, my smallest Y value is -9. And I actually see it written twice, but whenever we do our domain and range, we don't write the same number twice. So I would have -9, then -7, then -1, and then 7. That's how I would do domain and range from a set of points. If it was a table, again, my X values are my domain, and then the Y values are my range. So for my X values, I'm going to have, I'm going to make sure to go in order from the smallest to the largest. So -2, -1, then 2. For my range, I'm going to go from smallest to largest, -2, -1, 0, 1, 2. Notice that on the domain, I didn't write these duplicates, that -1, how it's written there twice. I only wrote it one time. And how the 2 is written there twice, I didn't write it twice. I wrote it only one time. So just by noticing that these x values repeat, I would want to make a note of something, that this is not a function. Because the x values repeat. And then if I'm looking at this one, the x values did not repeat, so this is a function. All right. Again, we're going to state the domain and range of each relation, but this one is from a discrete graph. So my domain is all of my x values, starting from the leftmost point. So this value is -3. And then this x value is -2. And notice this x value is also -2, but I'm only going to write it one time. But I also notice that that makes this not a function. This next point would be -1, 0, 1, 3, and then 4. For the range, we want to write our y values from lowest to highest. So my lowest y value would be this point right here, so -3, -2 for both of these. Then I'm going up to 1 for both of those, 2 for both of these here. And then this y value is 4. I did notice something. I noticed that this did not pass the vertical line test right here. So that would mean this is not a function. All right, for the domain and range on a mapping, these are pretty nice because they're listed straightforward. So my domain would be these x values, and none of them are repeating. If they were repeating, the arrow would kind of split into 2 arrows. So -3, -2, -1, 0, and 1. And then for the range, we're going to go from the smallest to largest, so 0, 2, 4, and 6. I noticed there's an 8 over here, but no value from the domain actually points to that range, so that's not actually a point in our range. So this would be a function. Finally, here's a little bit more vocabulary. This is about discrete and continuous. So you might have noticed, based on what we did yesterday, continuous graphs, like I don't have to pick up my pencil to draw it. It's a smooth curve or a smooth line it can be however many points on the graph. Whereas a discrete graph, it has individual points. So just kind of take that into consideration as we move forward. And another thing we've discussed a little bit was the vertical line test. You can use this on discrete and continuous graphs to see if it's a function or not. So what it would basically be is like this image where the vertical line only passes through one point on a graph, regardless of where I drew the vertical line. And if it does not pass the vertical line test, for instance, this one goes through 2 points or more, then this would be not a function. Here's a real-world example. This graph shows the length of the Tour de France in kilometers each year from 2000 to 2013. Is the relation discrete, that should say or continuous? Or continuous. So by the fact that I'm noting that I see individual points on this graph instead of a smooth curve or line, that would let me know that this is discrete. The next question is, does this graph represent a function? So what I would have to do is see if I can find any place on this graph where it does not pass the vertical line test. So vertical lines. And I'm looking, no matter where I draw a vertical line on this graph, it only goes through one point at a time. So does it represent a function? Yes, it does. And lastly, we're going to talk about evaluating. So you might have seen this in the past, f of x. So this is, f is a function. This is called a function. F of x equals 2x squared minus 8. We have to find each value here. We're looking for what is the value when x is 6, and we're looking for the value when x is 2y. So let's see how that would look. All I would have to do is anywhere in this function, anywhere that I see a x, I would replace it with a 6. So that would be here and here. So f of 6 is equal to 2 times 6 squared minus 8. So remember, when you do this, we're just simplifying, so I would want to make sure to go in order exponents first. 6 squared is 36. 2 times 36 is 72. And 72 minus 8 is 64. So f of 6 equals 64. So what this would mean would be at point 6, when my x value is 6, my y value would be 64. So if you wanted to write it as a coordinate, it would be like this. And then the next one, f of 2y, same thing. Everywhere I see an x, I'm going to replace it with 2y. So f of 2y would be equal to 2 times 2y squared minus 8. So let's see how that would look. Of course, I'm going to do the inside the parentheses first. One thing you have to remember is one of the rules of exponents tells me that if I have these two terms in here, I have a 2 and a y, both of them get raised to the squared power. So this would be 2 squared, which is 4, and then y squared, which is just y squared. Now I'm going to go ahead and multiply by 2. So this would be 8y squared minus 8. And there's nothing else I can do with that. I can't combine any like terms because there are no like terms. So this would be my answer. All right, that's it. Have a good day.